I want to blow your mind. Right now, you exist in a universe so vast and so profoundly mysterious that galaxies spin beyond your sight, and yet the smallest specks of reality, the quantum particles, dance to rules we can barely comprehend. But here is the question that begs an answer. What if an artificial intelligence could grasp the complexity of these quantum secrets before we even understand them? That single idea is unraveling the way we study the world, and it may be the turning point that changes our future forever. Behind each subatomic event, there is a swirling tapestry of probabilities and entanglements that defies human intuition. The next frontier might not be about bigger colliders, but about harnessing the power of AI to decode the cosmic puzzle. This is not a science fiction dream about hyper-intelligent robots overtaking humanity. It is a story of how researchers are harnessing code and algorithms to dive deeper into quantum realms than we ever thought possible. The secrets of existence might finally be within reach, and the catalyst for this revelation could be the digital neurons underpinning an AI. Are you ready to venture into the unknown? Let us push the boundaries of imagination and step beyond the ordinary into a realm where technology and quantum magic collide. Everything changes now. When physicists first discovered that tiny particles could be in multiple states at once, or pass through barriers that should have blocked them, they realized the micro world didn't behave like anything we'd ever known. Quantum physics flips intuition inside out, presenting phenomena so bizarre that even Nobel laureates sometimes do double takes. Attempting to simulate even a handful of interacting particles can balloon into a task so large that classical computers would need centuries, possibly millennia, to crunch the math. That is the heart of the quantum challenge, a realm governed by probabilities, interconnections, and wave-like behaviors that defy what our eyes see in daily life. Now imagine labs around the world collecting data at an astronomical scale, like the Large Hadron Collider spewing out petabytes of collision data each year. Hidden among that chaos could be clues to unknown forces, or even exotic forms of matter. But there is a catch. Human minds are not built to grasp that level of complexity with ease. We can only process so much, and we can only see the patterns our brains have evolved to see. In today's quest to solve quantum riddles, conventional approaches are often overwhelmed. Giants of science yearn for a more powerful ally, and that is exactly where the spark of AI enters the stage, igniting an entirely new pathway of discovery. At first glance, quantum theory looks like an unsolvable riddle. Exponential complexity, mind-bending equations, and phenomena so weird that they sound like jokes test even the brightest minds. Yet every now and then, a pattern emerges, a fleeting glimpse of order in the chaos. Traditional research teams can spend decades searching for one crucial insight in the sea of possibilities. But what if an entity could learn from billions of data points, spot a hidden correlation in seconds, and adapt with each new piece of evidence? This is the promise of AI-driven quantum investigations. By feeding monumental datasets into advanced machine learning architectures, scientists can highlight elusive quantum effects and refine experimental strategies. Gone are the days of passively sifting through noise for that magical eureka moment. Instead, machine intelligence can forcibly pull the signal from the static and redirect us toward findings we might never have noticed on our own. This is not about trusting a black box blindly, it's about supercharging our own creativity and rigor. Consider how an AI might propose a new configuration for a quantum circuit or a fresh approach to analyzing collider results. These leaps can slice through years of trial and error. The unexpected synergy between code and quanta shifts the entire paradigm, capturing attention and shaking up our assumptions about what is truly possible in the realm of physics. Throughout history, humanity has relied on genius intuition and slow, step-by-step reasoning to probe the frontiers of knowledge. But as quantum puzzles grow in intricacy, our eyes sometimes glaze over when confronted by monstrous equations. Enter the AI superbrain, fueled by algorithms designed to learn from experience and glean connections from staggering volumes of data. In a strange sense, it's as though we've invited an alien mind to collaborate on the greatest intellectual quest of our era. And sure, there's uncertainty, even fear. How do we ensure the AI's inferences align with physical reality? Are we ceding authority to a machine that might see patterns that aren't there? Yet the hope is equally potent. Imagine a research environment where no stony path is too steep, because AI can analyze multiple routes at once. Picture breakthroughs that used to be hypothetical becoming living prototypes. In this synergy, the raw horsepower of machine learning merges with the intuition and skepticism of scientists, safeguarding that each AI-proposed theorem or experiment is tested under rigorous conditions. This is not about replacing researchers, it's about lighting a fire under our collective ambition. The emotional core of quantum AI research stems from our drive to explore the unknown, to push beyond present limits. In that yearning, the technology becomes an ally in the most human of aspirations, discovery. Already, AI has accomplished feats that sound like science fiction. From discovering exotic new alloys to form sturdier quantum computing components to predicting how molecules will behave in complex chemical reactions, the impact is undeniable. Using machine learning algorithms, teams have spotted hidden anomalies in particle physics experiments far more swiftly than manual inspections could ever manage. In quantum computing labs, reinforcement learning optimizes how qubits are arranged and cooled, shedding precious milliseconds off decoherence and inching us closer to stable, large-scale quantum machines. There is a sensorial rush in the air, as though we are watching the dawn of a new era in real time. Each success story sparks fresh questions. What other secrets are locked behind data we've already collected but never properly examined? Might an algorithm unearth a brand new state of matter or a potential blueprint for a room temperature superconductor? The sense of momentum here isn't just about incremental updates. It's about rewriting entire textbooks if we find the right key. We stand at the cusp of transformations that could rewrite communication security, revolutionize biomedical research, and reshape the energy grid. The excitement is contagious because we realize that each little breakthrough fuels a chain reaction of discoveries, accelerating progress faster than any single scientist or lab could achieve by themselves. You might be wondering about tangible examples, and they're more impressive than you might think. Picture this: AI-driven models helping experts design superconductors that work at higher temperatures than previously dreamed of. It's not just blind guesswork. These algorithms have combed through material databases, used quantum mechanical predictions, and churned out credible candidates faster than any manual process could. Meanwhile, in the field of particle physics, AI has already accelerated analysis of collision debris from particle accelerators by orders of magnitude. Instead of hundreds of grad students painstakingly sifting through signals, machine intelligence zeroes in on potential breakthroughs quickly, giving researchers more time to verify them. In quantum chemistry labs, advanced neural nets are simulating molecules with astonishing accuracy. Drug development, which once took years, now stands to see reduced timelines as AI helps refine target structures for diseases with complex biochemical pathways. And if you think the synergy stops there, think again. In countless research groups, artificial intelligence is customizing experiment parameters in real time, automatically adjusting setups to gather the most statistically relevant data. These early wins aren't just ephemeral headlines. They're stepping stones that bolster our confidence in using AI to wrestle meaning from quantum complexities. With each triumph, the appetite for bigger and bolder investigations grows stronger. So what treasures might still be hidden in the swirling extravaganza of quantum data? Could an AI comb through astronomical observations and finally crack the enigma of dark matter? Perhaps it will discover a subtle pattern that leads us to an entirely new class of particles. The concept of a theory of everything, which unifies the weird world of quanta with the cosmic sweep of general relativity, has tantalized physicists for generations. Could AI spot symmetrical relationships or deeper invariants that hint at a union where human attempts have faltered? Some speculate that advanced algorithms might one day propose testable aspects of string theory or quantum gravity, bridging concepts that currently stand miles apart. Beyond the purely fundamental, we have quantum technologies forging forward. Imagine a scenario in which AI-optimized quantum circuits achieve error rates low enough to handle industrial-scale problems, revolutionizing encryption, communication, and data storage. Or consider personalized medicine, harnessing the synergy of AI and quantum simulations to design pharmaceuticals with near-surgical precision. Researchers might decode how quantum coherence in biological systems influences processes like photosynthesis or neural signaling. Each prospective breakthrough weaves into the next, forming a shimmering tapestry of discoveries that promise to reshape how we see ourselves, our planet, and the cosmos at large. The horizon is ablaze with potential. Yet any grand dream worth pursuing often arrives tethered to cautionary tales. As AI becomes a bigger force in quantum science, it also introduces new layers of risk. The algorithms we rely on can sometimes mislead us with spurious correlations, interpreting random noise as a groundbreaking signal. This black box phenomenon casts a shadow over enthusiastic findings, especially when even experts aren't sure how the AI arrived at its conclusion. Additionally, the thirst for data can become insatiable, forcing scientists to question whether we gather enough high-quality information to feed these hungry networks. In resource-limited fields, chasing massive data sets might sidetrack us from the deeper theoretical insights that only the human mind can craft. Then there's the ethical dimension. Do we trust AI to shape the next wave of radical theories, or do we keep the ultimate interpretive power in our own hands? Could the technology's biases, inherited from flawed training sets, guide us down erroneous paths? Balancing that edge between bold reliance and human oversight is tricky. Quantum AI is no magic wand. It's a sophisticated tool that demands vigilance, creativity, and humility. Amid the excitement of looming breakthroughs, it pays to remember that every leap in scientific capacity brings new responsibilities. Striking that equilibrium might be one of the century's greatest intellectual challenges. Picture a bustling laboratory where a team of engineers, physicists, and computer scientists huddle around glowing screens. The excitement is palpable, yet every triumphant shout is tempered by questions of verification. Instead of following an AI suggestion blindly, the researchers cross-check the results against known formulas, run smaller tests, and engage in good old scientific debate. This dynamic recognizes that the best breakthroughs happen when we weld machine efficiency to human insight, forging a partnership neither could achieve alone. Part of taming quantum AI lies in building interpretability methods that peel back the logic behind an algorithm's predictions. Another component is crowdsourced collaboration, where open data platforms let scientists worldwide replicate experiments, refine code, and spotlight anomalies. In a sense, the quantum AI revolution echoes older scientific renaissances, a wave of new instruments that unites diverse thinkers eager to push boundaries. But it also runs deeper, requiring a shift in mindset. From seeing AI as a final oracle to embracing it as a collaborator that offers a perspective both alien and illuminating. Harvesting this synergy responsibly could speed us closer to fundamental truths about space, time, and matter. And at the intersection of technology and pure wonder, quantum AI stands poised to shape the next epoch of human curiosity, magnifying our capacity to marvel at the wonders that lie just beyond reach. Peer into the near future and you might see quantum labs in constant dialogue with powerful AI clusters, fueling a cascade of insights that spark daily headlines. The synergy is unstoppable. We might see the unveiling of data-driven theories that unify the four fundamental forces, or witness precision quantum sensors diagnosing diseases in mere hours. Scientists might even harness AI to refine how we interpret quantum mechanics itself, bridging gaps that have persisted for nearly a century. AI's capacity to hypothesize and test enormous mathematical frameworks could propose reinterpretations of entanglement or pave the way for novel quantum fields we didn't know existed. Tomorrow's labs will likely blur the line between classical computing, quantum hardware, and adaptive algorithms, generating discoveries at a rate that dwarfs today's output. And it could extend beyond pure science. Imagine architectural designs shaped by quantum-level simulations or entire energy grids that use quantum optimization to slash inefficiencies. The synergy is not just an improvement, it's an evolution in how we approach problem solving. Indeed, as quantum physics continues to puzzle us and AI continues to refine its methods, their union signals a revolution in intellectual possibility. Are we on the cusp of a new golden age, a renaissance fueled by digital minds that see beyond conventional limits? If so, the last 100 years of physics might just be the prelude to an era where unstoppable curiosity meets unparalleled computational force. Here we stand, drawn to a threshold that fuses the most mysterious science on Earth with an intelligence born from code. As the veil lifts, new possibilities flood our imagination. So I leave you with this question. Which quantum secret do you believe AI will crack first? Shortcuts to new particles? Insights into cosmic dark matter? Or a unifying approach that finally merges general relativity with the quantum realm? Let your mind roam wild and share your thoughts in the comments below. If you enjoyed this deep dive into the future of science and discovery, show a little love by hitting the thumbs up button, subscribe to help us continue exploring the strangest corners of technology and the cosmos, and ring that notification bell so you never miss our next journey. Thank you for joining this quest, and remember to keep questioning the fabric of reality, because in that curiosity, you become part of the unfolding narrative that will shape the world for generations to come.